Good day, dear colleagues. I am Ustinov Maxim Sergeyevich, Senior Assistant of Professor of Department of Diagnostics Radiology and Radiology Therapy, MD, PhD. Today we discuss about X-ray research methods. But we begin the lecture with a very complex concept about functional images. The authors of this concept are scientists, professors Igor Petrovich Korolyuk and Leonid Davidovich Lindenbraten. They believed that the diagnosis should be made by someone who can. According to this concept, there are four types of functional images. Functional images type 1 characterize motor activity or motor function. For example, first example, contrast esophagus or stomach radiography or fluoroscopy. The second sample is all ultrasound examinations. And third, it's heart muscle examination by computer tomography, magnetic resonance images, and single photon emission computer tomography. Look at this picture. There is contrast stomach radiography. We will see motor activity. Functional images type 2 characterize accumulative and excretory function of some organs. For example, excretory urography, X-ray examination, or radionuclide examination, hepatobilicenography. Look at this picture. On the right side, we see excretory urography, X-ray examination. On the left side is hepatobilicenography. Next type of functional images, type 3 or type 3, characterize perfusion. What does mean perfusion? Is blood flow through the organ. Examination of brain, for example, brain CT, computer tomography, or brain MRI, when we diagnose stroke. Next sample, next case is contrast enhanced lung computer tomography, diagnosis of pulmonary embolism. And third sample is myocard computer tomography, diagnosis myocardial infarction. And on this picture, we may see on the right side brain MRI, and on the left side, and on the right side we see contrast enhanced computer tomography. And fourth type of functional images of this concept is characterize metabolism. For example, brain metabolic MRI, magnetic resonance images, or positronic emission tomography. Another type, uh, MRI nerves of spinal cord. The first and second samples characterize record oxygen saturation of brain or nerves. And third example of functional images type 4 is radionuclide thyroid gland scintigraphy. Thyroid gland scintigraphy record increase function of thyroid gland. Look at this picture. On the left side, there is brain MRI, and on the right side is thyroid gland scintigraphy. Let's discuss another important concept of modern radiation diagnostics: computer diagnostic support. If imaging and radiation diagnostic are faced with a large-scale task of evaluating hundreds, thousands, or more images, then other processing mechanisms are required: a higher degree of reliability and speed than the work of a single radiologist. To solve such problems, the use of computer diagnostic support system is required. These systems are divided into two types. The first is the hint system. It's computer assisted detection. Identification of localization and prevalence of pathological changes in the medical image. The result is a topical hint and an objective assessment of the extent of the lesion. This is a great help to radiologists in cases when their own resources, energy, and efficiency are not enough. The radiologist is in a state of constant attention for many hours, and these resources are always limited for a person. The second group of CAD system is computer support for diagnosis. Computer-aided diagnosis. Nosological characterization of changes. This is a situation when this system, trained by us with the help of a neural network, performs nosological diagnostics. That is, the computer indicates a certain disease or group of diseases. For example, an indication of the nature of the tumor process, benign or malignant. This work of the CAD system is already approaching what is now more and more in demand, namely the artificial intelligence system. This system works when the boundary of visual perception has been reached and we cannot move further to the correct diagnosis. This slide the slide shows illustration of the CID system. This is the first group of the CAD system. The system scans an X-ray of the chest cavity organs and show foci that the doctor can either confirm or reject. This is a system of localization of pathological foci, which reduces the risk of error or omission of the disease. There is a way that dramatically reduced the likelihood of an error. This is a second opinion or a second view. In this case, a computer system can act as a second opinion. The system has competences for recognizing formations that a person can easily miss. The following slide shows an illustration of a computer-assisted diagnosis system. The system differentiates the norm and pathology based on previous training. A new direction in radiation diagnostic, radionomics, belongs to the same system. In this direction, the data of genetic laboratory studies with detailed analysis of images are synthesized, which make it possible to predict the course of the disease and ensure correct diagnosis. In this case, CAD system differentiate benign and malignant tumors of breast. The following slide shows an illustration of a computer diagnosis support system developed in Samara State Medical University for the diagnosis of lung damage in coronavirus infection. This system, created on the basis of artificial intelligence, provides calculation of the percentage of lung tissue damage. Also, this system is able to calculate separately the percentage of damage by the type of ground glass opacity and consolidation. Samara State Medical University is one of the leading research centers in Russia in the field of IT technologies. The next slide presents developments regarding the planning and execution of operation based on a three-dimensional model of the liver based on computed tomography. This system is called AutoPlan. It allows you to build a personalized pathology model and help the surgeon plan the operation and act more reliably. Precise planning of access to the liver allows to avoid intraoperative bleeding from the arteries feeding the liver when part of the organ is removed. The highest manifestation of the system is the creation of augmented reality within the operating room. In other words, the reality on the operating table is complemented with the help of visualization method of radiation diagnostics. This is a great potential for future scientific research. And now we continue to the X-rays research methods. The discovery of X-rays and radioactivity at the end of the 19th century served as the basis for the development of a new direction in medical science, radiology, and then radiological diagnostics. On this slide, you see Wilhelm Conrad Röntgen discovered X-ray on 8th of November 1895. He was awarded by Nobel Prize in Physics in 1901. In the center, Henry Becquerel discovered radioactivity 1st March 1896, and Pierre and Marie Curie they were awarded Nobel Prize in Physics in 1903. Definition of radiology. Radiology, the field of clinical medicine, which studies the structure and function of human organs and systems using X-ray radiation. And X-ray diagnostics, recognition of diseases by X-ray data for the provision of emergency medical care, and determination of the localization of pathological changes relevant. At this picture, we see first radiograph of wife Röntgen, Bertha Röntgen, made 22 December 1895 and published in the article on a new type of rays on 28th December 1895 in the Journal of the Würzburg Physics and Medicine Society. On this slide represent This slide represents history of development of radiology, more in Russia. 19, sorry, 1896 started at St. Petersburg and Moscow University learning method. Researcher Tankov reported results of the study of the structure of the skeleton. 1906 renal X-ray imaging was performed. 1910 and 10 barium sulfate contrast agent is offered. In 1918 was founded a radiological and oncological institute in St. Petersburg, the first time in the world. At the same year, pneumoencephalography and pneumoperitoneum are offered. In 1922, performed myelography and cholecystography. In 1927, angiography of cerebral vessels was performed by Monitz in Soviet Union. In 1929, performed aortography by direct puncture. At the same year, the principle of longitudinal tomography was developed. In 1930, water-soluble iodine-containing ionic contrast medical for intravascular administration were synthesized. Look at this picture. This picture describes X-ray examination of chest cavity organs in 1902. This is very dangerous because there are no anti-X-ray defense. At this slide, there are outstanding radiographers on first decade of the 20th century in Russia and Soviet Union. There are Grigoriev, Korolko, Kochetov, Samoilov, Rosenblatt, Yanovsky. Later, Eisenstein, Budinov, Golst, Den, Nemenov, and others. S.R. Frankel, the first head of the first department of radiology, founded in 1935 at Medical Faculty of Moscow University. Later, the Moscow Medical Academy by Sechenov. In the middle and second half of the 20th century, outstanding radiographers are Zedzhenidze, Lagunova, Lindenbratton, Pavlov, Rabkin, Reinberg, Sokolov, Tager, Schechter, and other researchers have enriched domestic and world science with important information about the new possibilities of the X-ray method. In this picture, there are the first X-ray machine and exterior view of the building of the uh, Röntgen laboratory. Uh, the principle of obtaining an X-ray image is on this slide. We have radiation source. We see object, and after object we see receiving device. On this slide we have schematic representation of an X-ray tube. What is devices of the X-ray machine? The first component is control panel. The next component is generator. Generator generates a voltage that is applied to X-ray tube, and the main part of the X-ray machine is X-ray tube. Directed flow of charges, particles, electrons is created. The flow goes from the cathode to anode. At the moment of electron deceleration, X-ray radiation is generated when reflected from the anode. The anode has a round shape and is called an anode mirror. The anode is constantly rotation, so that the electrons are reflected from different parts and do not overheat the anode. The next part of X-ray machine is collimator. Collimator restricts the window of X-ray coming out of the X-ray tube. And last is ionizing radiation receiver. What is physical properties of X-rays? X-rays penetrates bodies and objects that do not transmit light. X-rays causes glow of a number of chemical compounds. X-rays decomposed silver salts. X-ray ionizes atoms. Induces scintillation in crystals, and X-ray has a biological effect. Projection imaging technologies in radiology. There are two main types of images. First is analogical or analog. That mean on X-ray film or fluorescent screen without use of computer technology. And the second main image is digital. Digital using computer technology. On this slide represent principal scheme of receiving an analogical image. X-rays goes from tube through the patient to image to ionizing radiation receiver. In this case, is a sensitive film. And in another type, receiving a digital image, X-ray goes from X-ray tube through the patient and goes to detector. Detector scanning, then handling and recording digital image. On this slide, you can see a universal analogical or analog X-ray diagnostic device. We can see patient, we can see in the center X-ray tube and radiologist or X-ray technique. The main types of X-ray detectors. The first type is X-ray film. And the method of this type is X-ray diagnostic, X-ray examination. The second is fluorescent screen using in fluoroscopy. And the third is digital matrix using in digital radiography and digital fluoroscopy. On this slide, we have main X-ray methods. For example, first, radiography, analog or analogical and digital, different types. The second is fluorography. Third is fluoroscopy. And fourth is tomography. Let's talk about radiography. X-ray. Greek for right, depict, synonym X-ray. Image of the object is fixed on a light sensitive material, analog technology, in magneto-optical memory or on another medium, digital technology. Plain X-ray is an image of the entire anatomical area. A targeted X-ray is an image of a part of an object in an optimal projection. Contact X-ray is an image of an object is obtained by direct contact of an X-ray film with a body surface or mucous membrane. Serial X-ray is designed to study the dynamics of a rapidly flowing process. Radiography. Direct magnification radiography is performed to obtain an enlarged image with an increased distance between the object on the study and the X-ray film. Close focus radiography, or plesiography from Greek, plesios close, is carried out to study small anatomical formation at a close distance, radiation source to object of study. X-ray is the most important and most frequently used method of X-ray examination. Science at a relatively low cost, it gives an image that is as close as possible to the true dimensions of morphological objects. The next method is fluoroscopy. Greek skopea is look, observe, synonym fluoroscopy. Fluoroscopy is a method of X-ray examination in which the image of an object is studied on a luminous fluorescent screen or digital fluoroscopy. Radiography and fluoroscopy, the main methods of X-ray examination. The study is performed in vertical, horizontal, or inclined position, which makes it possible to judge the displacement of organs and the presence of some signs associated with a change in the position of located structures. An image of human organs and systems during X-ray examination can be obtained using natural contrast or artificial using contrast medical. X-ray contrast agents with high atomic mass, air, and low atomic mass, barium sulfate, water soluble. Both ionic and non-ionic are used. X-ray examination can be performed with two contrast agents. Double contrast used in the study of the gastrointestinal tract. Based on the basic methods of X-ray examination, various special techniques have been developed to solve specific clinical problems. X-ray methods allow you to study the shape, size, position of the structure of human organs and systems. The next method of X-ray examination is fluorography. Fluorography is an X-ray examination technique in which an image is photographed from a fluorescent X-ray screen onto a small format film of 110 to 110 or 100 to 100 or 70 to 70 size or digital fluorography. Format of 100 to 100 millimeters, named also large frame fluorography. Next, uh, the next method of X-ray examination is longitudinal tomography imaging, or uh, linear tomography. Tomography, from the Greek tomos, layer, is a method of layer by layer X-ray examination. On this slide represent principal scheme of created linear tomography. On a conventional radiograph, a summary image of the entire thickness of the examined part of the body is obtained. Longitudinal or linear tomography allows you to obtain an image of one isolated layer of the investigated area. Principles of X-ray image analysis. X-ray radiation, which has passed through less dense areas of the human body, lung tissue, air in the gastrointestinal tract, causes a bright glow of the screen and is defined by the term enlightenment. Dense structures, heart, bone, skeleton, liver, which have significantly absorbed X-ray radiation, form dark areas on the screen, shadows. In radiography, radiologists evaluated a negative image in which the image of organs is directly opposite to the color scale of the image on the screen. However, the color image on the X-ray is displayed as it appears on the screen. Plain X-ray of the chest organs. In frontal, direct and left lateral or side projections. Visible. The anatomical structures that form the skeleton of the chest and mediastinum. This is shadow. The diaphragm and the abdominal organs under it, the shadow. But pulmonary fields is enlightenment. Roots and pulmonary pattern, shadow. Multi-projection studies in determining the location of a foreign body in the chest. You see foreign body in the soft tissues of the back. When analyzing an X-ray image, its details located at different depths of the body are zoomed up into a common shadow. Therefore, the localization of the pathological process is possible only if there are at least a radiograph in two projections. There is plain X-ray of the abdominal organs. There is liver, dark shadow, on the right side, gas in the intestine, enlightenment, and in the bottom of this picture, pelvis bones. They are dark called shadow. The next sample, plain radiography pelvic area. There are pelvic bones, shadow. The area in the right and left hip joints, also shadow. Uh, Another type, shoulder X-ray. On the left picture is overview, but in the right is sighting. Next sample is radiographs of the distal lower limb and foot. We can see bone marrow canal, compact substances bones, X-ray joint space, also spongy substances. The structure of the bone tissue is determined. On this picture, we can see hand radiographs from child different years, up to 3 years, then 3 years, 9 years, and 16 years. Age of features of skeletal ossification, and we can see ossification nuclei and growth zones. Growth of skeleton lasts up to until 25 years. The next slide is about contrast substances used in X-ray examination. Contrast substances can make invisible organs become visible. The main types of contrast agents is reducing absorption coefficient and increasing absorption coefficient. Classification of X-ray contrast substances. They divided by X-ray positive and X-ray negative contrast substances. X-ray negative are gases, are air or xenon. X-ray positive divided by two groups. First group is X-ray positive contrast substances containing barium are used to study the gastrointestinal tract. And second group is iodine containing. Iodine containing contrast substances divided by water soluble and fat soluble. Water soluble iodine containing contrast substances are used for study where blood flows, blood vessels, heart, urinary system, or urinary tract. And the second group of iodine containing contrast substances, fat soluble. They are used for the study of fistulas, salivary gland ducts, bronchography, lymphography, and the study of the uterus. For the study of biliary system, both water-soluble and fat-soluble iodine-containing X-ray contrast substances are used. Contraindications to the administration of contrast agents are renal failure or chronic kidney disease, and the complication of using uh, iodine containing contrast substances is pseudo-allergical reaction with a very dangerous complication, anaphylactoid shock. We are going to special research methods using contrasting organs and system. And we are view some types of X-ray, special X-ray diagnostic techniques. First is bronchography of the right lung, direct projection, and lobar and segmental bronchi are contrasted using iodine-containing fat-soluble contrast substances. But this method is now not allows because diagnostic of bronchoectatic disease is used on computer tomography. The next slide is pneumoencephalography of the skull. This arrow indicated air-filled ventricles of the brain. The next method, contrast breakfast, in the study of the esophagus. Arrows indicate the passage of air along with barium through the esophagus. This is functional imaging type 1. The next slide. Method contrast breakfast in the study of stomach. Citing radiographs. On the left image, we can see relief of mucous membrane of the body is not tight filling, and on right side we can see antrum of the stomach and duodenal bulb, dense filling by contrast substances containing barium. The next technique, special technique, is relaxation duodenography. And we can see relaxed duodenum and duodenal probe. The next method we follow down to gastrointestinal tract. It's enterography, and using barium containing contrast substances, and we can see probe, a live probe, and enlarged lumen of the small intestine. Next slide is plain X-ray of the colon, called irrigoscopy or irrigography. And we can see transverse colon, the standing, sigmoid colon, polypositional study, double contrasting. In the intestinal lumen, we can see barium containing contrast substances and gas. Double contrasting meaning using two contrast agents, gas and barium. The next slide is excretory urography. This is functional imaging type 2. And we can see cups on the left and right side. We can use both ureters, we can use pelvis and contrast substances in urinary bladder. Excretory urography in direct projection, and we can see excretion of contrast agents by the kidney. The next sample, hysterosalpingography in direct projection. This is contrast examination. We use iodine containing fat soluble contrast substances and contrasted 1. The body of uterus, 2. Fallopian tubes, and 3. Contrast agents in the abdominal cavity on both sides, more on the left. The next sample is also contrast method using iodine containing fat soluble contrast agents, and we can see para-aortic lymph nodes, iliac lymph nodes, pelvic lymph nodes, inguinal lymph nodes, accumulation of contrast agents in the lymph nodes. The next sample is combined method. It's endoscopic retrograde cholangiopancreatography. In the digit number 1 is distal end of the endoscope in duodenum, and then on 3 all elements of biliary system are contrasted. We can see bile duct and liver ducts, and on digit number 4 we can see main pancreatic duct. This is also a special method of X-ray diagnostics. Another special types of X-ray diagnostic. This is mammography. Mammography is a special method of X-ray diagnostic with high dose to differentiate soft tissues. And we can see leather, then we can see subcutaneously adipose tissue, we can see vessels, and glandular the cloth. This method is necessary to take women's more than 40 years to detect and screening of breast cancer. It's a very important method. Another picture. This is orthopantogram of teeth and jaws. Allows you to simultaneously visualize the structure of teeth, upper and lower jaws. This method is often used in stomatology. On this picture, we can see X-ray of lungs and linear or longitudinal tomogram of lung. And we can see in both on the left side is X-ray of lungs, and on the right side is linear tomogram of lungs. And we can see trachea and trachea bifurcation, left and right main bronchus, number 3, left upper lobar bronchus, number 4, and number 5, the right upper lobe bronchus is not traced due to pathological process in the upper lobe of the right lung called atelectasis. And longitudinal or linear tomogram let doctors see in detail pathological of right upper lobe. Linear tomogram is a previous stage of the next very important X-ray technology is computed tomography. You will listen a special lecture about computer tomography, but in today's lecture we remember some aspects of computer tomography. Computer tomography is OCT is a layered radiation study based on computer image reconstruction by processing information from detectors about the absorption of radiation in the internal structures of the human body during circular scanning with a beam of X-rays. Why we we have different view of some organs and pathological objects in computer tomography. It's realized by density measurement. Density measurement used in Hounsfield scale. There are etalone plus 1000 Hounsfield units is bone density, minus 1000 Hounsfield units is air density, and between these digits, zero Hounsfield units is water density. There is Hounsfield scale, and between plus 0 plus 1000 and minus 1000, all anatomic organs and all pathological foci are situated. There are three projections or three planes in computer tomography. Axial plane or projection divides the body into upper and lower halves. The next plane or projection is sagittal. Sagittal plane or sagittal projection divides into right and left halves. And third projection is coronal plane or coronal projection, passes through the heart and divides into anterior and posterior halves. And last slide about computer tomography. You have to remember the image viewing windows. Some organs better viewing in some Hounsfield units, count Hounsfield units, and in workstation of radiologist of computer tomography, or in special soft to viewing DICOM files, we have to choose different image viewing windows to better view some organs. And first window is bone window, plus 1000 Hounsfield units. The second, if we have to see lungs and diagnosis lung disease, we have to choose lung window from plus 600 Hounsfield unit to minus 1600 Hounsfield units. Third image viewing window is soft tissue window, plus 300 Hounsfield unit. And fourth main viewing window is mediastinal window, plus 500 Hounsfield unit. The lecture number 2 is over. Thank you for your attention.